All right, everyone, we're back again, and this time we're looking at another periodic trend. So what I have here is something that can happen in many different situations where you've got some kind of form of energy. Usually we have electromagnetic energy, so it's going to be form of some kind of electromagnetic radiation, usually like UV light or X-rays. And when these hit an atom, what can happen is the outermost electrons can be knocked out. And when that happens is if you lose the electrons, you end up with a positively charged cation, and the electron is free. So it's going to move, and eventually it's going to be absorbed by another atom or molecule. So the amount of energy it takes is actually specific for each atom, and it's called the ionization energy for that particular atom. And this varies between atoms. So let's look at lithium. So if you look at lithium, the amount of energy it takes to knock out the outermost electron, you have a single outer electron here, is 520 joules per mole. Don't worry about the units. Now let's look at neon. Now remember, neon has a full outer valence orbital. And what that means is it looks like it takes a lot more energy to knock off that electron. And it kind of makes sense. It's very difficult to remove electrons in neon because it has a full outer level versus lithium, where it doesn't even want that electron. It'd rather lose the electron because then it's going to have a stable inner outer valence orbital. So basically, the energy really depends on how many valence electrons you have and how close you are to a full outer level. So let's look at this. So make sure you recognize the diagram. It's a very easy diagram. So basically adding energy to remove an electron. So over here you should have this. There we go. You have a positive cation, and you're going to have some electron that's zooming around somewhere. So the definition is the minimum amount of energy required to remove an electron from an atom, and usually we look at gases. The harder it is to remove the electron from the atom, the higher the ionization energy. So guess what? Who has the highest ionization energy? Well, it's going to be the noble gases here. And the reason is they are closest to a complete, or they have a complete outer valence orbital. And the closer you are to that complete orbital, the closer you are, the less likely you are to lose electrons. So as you're going across, it's harder and harder and harder to remove those outer electrons. So the ionization energy increases. So going across, this is B lines. You're going across, it's higher. Now what happens here vertically? Well, here's the thing. You have to think about how far these outer electrons are from the nucleus. Remember, the nucleus is positively charged, right? And it's pulling on those outer electrons. Well, if those outer electrons are really far, there's not much attraction there. But if those valence electrons are very close, there's a lot more attraction. So helium has a complete orbital, and it also has its electron orbital very close to the nucleus. So as a result, it has the highest ionization energy. So the idea is this. As you're going across to the right and then upwards, the ionization energy increases. So very straightforward there. Okay? Now, let's look at lithium again. Now remember, lithium, to remove this outer electron, only took 520 joules of energy per mole. We call it the first ionization energy. We're trying to get rid of this first electron. Now, what if I have lithium, the lithium positive here, so remember it's a cation. What if I tried removing the next electron, the second electron? This is called the second ionization energy. So if I try to do that, it takes an incredibly larger amount of energy. And the reason is, why would lithium positive want to lose an electron? It's already super stable, having this outer level, or this valence shell, full. So basically, the ionization energy really depends on what group you're in. So for example, if I'm in group 1, So let's look at an example of an alkali metal, sodium. Remember, you want to lose the electron. So it's very, very easy to lose that first electron, but then it's very hard because you're going to have a full level. Magnesium, it wants to lose 2. So it's very easy to lose 2 electrons, and the other, then it becomes very, very hard once it achieves its full outer orbital. And similarly, aluminum it's easy to lose 3. And then how about the other end? Well, what about argon? Well, argon, look how high this is. It's hard to even remove the first valence electron. And the reason is simply because it's already stable. It has a full outer level. Now let's look at chlorine. Now chlorine, it's very, very hard to remove the electron here because look, it's very close to having a full orbital. It only needs one more. Why would it want to lose an electron? So as you're going across, it becomes harder and harder to remove the electrons because of the fact you're closer to this outer level. And you should be able to identify what element is in what group just based on the number of the ionization energy. Look at the first, second, and third. It kind of makes sense. All right, so that's it. Next video is going to be electron affinity, opposite of this.